Huh? Okay, bit. What is a bit? You know that you learn when you learn about everything about the computer, everything you know the bit, right? The bit it is a it carry out information or zero or one. Huh? The bit it carry out information about zero and one here, zero and one. And the reason zero and one because the computer is made up of million switches, right? For the switch, and whenever it's on, you have number one, and off, you have number zero here. Right? Okay, so from the binary here, you will just combine the every communication of the byte, you make it up for image, for the sound, for the file. Everything come up from zero and one here. Right? Okay, so now you know that for one bit, you have two values for that, zero and one here. Now my question here, if I have two bits, how many combinations I can have? Four, right? You have zero, zero, you have zero, one, you have one, zero, and you have one, one, right? So if I have three bits, how many communication? Sorry, how many combination I have? Eight, right? So yeah, so basically the formula here, the formula here, if you have n bits, so in total you have 2 raised to power of n combination. Right? So if you have this, if you have 3 bit here, you have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, right? 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1 here. Right? So basically that is the formula. If you have n bits, you have 2 raised to power n combination here. Okay, so now the reason I explain the concept of bit here because for every computer, the address here also is a combination of bit here. So in general, you have the two version. You have the two version of IP address. The first one is the IP v4, that means IP version 4. And the second one, you have IP v6, that means IP version 6. So most of the time in this class, we learn about the IP version 4 here. So let me explain about the concept of IP version 4 first. So for IP version 4, in total, you have 32 bits of address. Right? And you know that if you have the 32 bit of address, you have 2 raised to power of 32, you have about 4 billion. 4 billion address. And you know that nowadays 4 billion is not enough, right? You see, each of you have multiple devices here, right? You have the tablets, and you have iPhone, iPad, and so on, a thermostat, everything, right? So that's why the IP7.4 here is already done now. That's why they come up with the IP7.6. IP7.6 in total, you have 128 bits. And you know that if you have 2 raised to power 128 bits, I don't know. I cannot tell the number here. You have trillion, right? But again, the most concept we learn in this class is about the IPv4. So I will explain it to you how you work with the IPv4 here and how can you do and how can you manipulate with the IPv4. I need to have stylus here. Okay. Okay, so now let's talk about the IPv4. You have 32 bits. In total, we have the 32 bits. And represent by core group, one here, one here, one here, and one here. And each group, you have 8 bits here. And you know that 8 bits is called the byte, right? But in the IPv4, they call it is octet here. Octet. So remember, one octet, you have 8 bits. Right? So they break it down they break it down by the dot here. Right? So think about I have 1, 1, 1, 0, 0, 0, 1. I dot it here, right? 1, 2, 3, 4, 5, 6, 7. One more, right? Okay. And each of them, each group here, they separate by the dot here. Right? By the dot here. And you see that for every computer, you in total you have the 32 bit here, and they break it down by everything 0 and 1, 0 and 1, and so on. Now, for 0 and 1, 0 and 1 here, 32 bit 0 and 1, it's really hard for you to remember. Right? It's really hard. So that's why in order to make it easier, they convert it from binary to decimal. Decimal, that means everything from 0 to 9. That's the number, digit here, everything from 0 to 9. Okay, so in order to convert here, I need you to know the concept, how you convert from binary number to the decimal number. You know that binary number here. Binary here, right? You have everything 0 and 1 only. But decimal, right? You have everything from 0, 1, 2, come all over to 9 here, right? Okay. So the concept here, let me give you the number about 999 here. That is decimal number. Right? So if you look on this one, you have 3 digits of 9, but the value is not the same. Right? This one here, actually, this one is 900. Right? So the digit here 9, but the value is 900. This one is 90 here, and this one 9. So it depends on the location, on the column here, right? So we see this one is unit column. Right? One column, actually, one column. This one is the 10 column. And this one is 100 column, right? That's why you have 900 here, you have 90 here, and you have 90. So the concept, it works exactly the same when you work with the binary number. Right? Think about this one. Think about, I have the binary number here. I have binary number here. 1, 1, 0, 1, 1. Okay. They break it down into multiple columns here. Right? Again, for this one is one column. Right? Actually, it's 0 here. Right? This 0 here. This one is number 1. This one number 2. This one number 3, and this one number 4. And let me do it one more here, right? Number 5, number 6, and number 7. So basically, when you convert in the binary, you have 1 byte, right? 1 byte, that means 8 bit here, right? So 8 bit, it's everything from 0 to 7, you have 8 bits, right? For each of the column, you have specific value for that. Right? So see, when you work with the binary here, the base here is number 2, right? The base here number 2. So the value of the column here, it is 0, 2 raised to the power 0, right? 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, and 2 raised to the power 6, and 2 raised to the power 7. So you have the 8 bit. You have 8 bit, right? So this one, 2 raised to the power 0, what is it? Number 1, right? Number 1 here. So the value for this column here, number 1, you double it, you have number 2 here. You double it, you have number 4, number 8, number 16, number 32, number 64, and number 128. Right? Okay, that's all. So you see, if I have the binary number 1, 1, 0, 1, 1 here, what does it mean? I have 1 of 16 here, right? I have 1 of 16 here. I have 1 of 8 here. I have 0 of 4 here. I have 1 of 2 here. And I have 1 of 1 here. So I sum it up together. I have decimal number. Make sense? I have decimal number here. So I have 24 here, 26 and 27 here. So when I convert this one, I have 27 here. Make sense? That's the way you convert from the binary to the decimal here. Make sense? Okay? It depends on the value of column. Right? So remember that you have 8 bit here. Remember this one is number 1, number 2, number 4, number 8, number 16, 32, 64, and 128. That's all you are required to remember when you work with the conversion from 1 byte to the binary, because you have 8 bits here. Is that okay? Now I explain it to you the concept how you convert it from a binary to decimal here, but I do not require you to do it manually. Right? So if you want to do it, you can use a calculator. I just explained the concept of it. But in this class here, it's up to you. You can do it manually, or you can use a calculator here. So in the case you use a calculator, right? In the case you use a calculator here, you can choose the option. You can choose the option here. you can choose option when you work with programmer. Yes, I think programmer here, right? So think about this one here. I have, oh no, I have 1, 1, 0, 1, 1, 1, 0, and 1. And you can see how I convert it here. Right? For this one, I have to, sorry, I have to choose for binary first, right? So you see, if I choose for binary, I only have two possible values here, 0 and 1, right?
Is this a special calculator or is this a?
No, in the window here, right? Or any calculator you can see it. Yeah. So see, if I have 1, 1, 0, 1, 1, 0, 0, 1, and you see that is a I have the binary here, right? So make it here, 8 bit here, right? So I see this is a binary. When I convert it decimal, I have 236 here. When I convert it into the hexadecimal, I have EC here. Right? That's the way you use the calculator in this class. But again, it's up to you. You can do it manually. That's the way I show you here, or you can use the calculator. Right? Okay, so that is the way you convert from the decimal to from the binary to decimal. Now, the question here, you know that how to convert it from the binary to decimal. The question here, how I convert it from decimal? How can I convert it from decimal back to the binary? So basically, the concept here again, you have to understand the value of the column. You have to understand the value of column here, right? So again, I have 0 here, I have 1, I have 2, I have 3, I have 4. I think I should use this one, right? So again, I have 0, 1, 2, 3, 4, 5, 6, and 7 here. I have 1 byte, 8 bit here. And I have 0, 1, 2, 3, 4, 5, right? I have to know the value of each column here. 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, right? Okay, so I know the value for this column here, it is number 1, number 2, number 4, 8, 16, 32, 64, and 128. Okay, so you know that is a 1 byte, 8 bit here. And what do you think? What is the maximum value of 1 byte in decimal?
6.
What do you think? What is the maximum value of 1 byte in decimal? 255. Actually 255, right?
0 to 2.
So you see, if you have put 1, 1, 1, 1, 1, 1, 1, 1 here, you see, you sum it up together. You sum it up here, right? 128, 164, 132, 116, 18, 14, 12, and 11. You sum it up together. You have 255. Right? So that's why you see that when you look into the IP address here, the maximum number is a 255 and the minimum number is 0. So when all of them 0 here. Is that? Never ever put anything to 300 or 400. Right? Okay. Now, I explain it to you now. How can you convert it from decimal here back to the binary? Okay, so think about, in the case I have the decimal number 200. So how can I convert it? So in order to convert from the decimal to binary, you have to work from the left to the right. You have starting from the highest number first, right? So in order to make up 200 here, do you need 228? Yes. So if you need 128 here, you have to put the number 1 here, right? You need it. So we know that you already have 128 here, so we minus 128. So what I have left here, I have 2, I have 7 left, right? So I have the 72 left, right? So now I move to the right. Now, in order to make it up for 72, I need 64 for sure, right? So I put number 1 here. Now I need 64, so I have to minus it. I have 8 left. In order to make up 8, I don't need 32, right? That's why I put 0 here. I don't need 16 here. I put 0 here. I need 8 here, right? It's a perfect here, right? So see, I minus 8 here. I have 0 left. That's why I have 0, 0, 0 here. Right? So you see, 200 here. When I convert it to the binary, I have 1, 1, 0, 0, 1, 0, 0, 0. That's the way you convert it here. But again, I do not require you to do it manually. You can use the calculator here. It's up to you, right? So see, if you use the calculator here, use the calculator here, you can see, you go over to the decimal, you click on decimal here, and you put down the number 200 here, and you can see, you convert it here, right? You have 1100, 1000, right? And you know that I expected that you know how to convert it using the manually, or you can use the calculator here, because later on, when you work with the IP version 4, when you work with the what is it? When you work with segmentation, you know the process, how you break it down here. Okay, what's your question?
In the real world, do you recommend I know how to count versus the calculator?
It's up to you. Because in the real world now, you know that nowadays you have many tools go with you, right? You have the calculator, you have the phone, whatever, ChatGPT.
Okay.
Right? Oh yeah, I don't have you. Many assignment or many work you can use the ChatGPT, but at least you have to know how to convert it into the ChatGPT, right? You how to give the correct prompt here. Okay, okay, it's up to you. Okay, but again, whatever it you manually or you use the calculator, you have to know how to process, how to convert it here, right? Back and forth. Okay, now I come back to the IP version 4 concept. I go back to the IP version 4 concept. Oh, I think it's a natural theory. Okay, so we guys take a short break for 5 minutes and we come back. Okay, so now we go on. I explained it to you about structure of IP version 4, right? IP version 4 is 32-bit, right? And it represented by the 32-bit, and you see they by 4 group, right? They have 4 group here, and you see you have 8-bit, 8-bit, and 8-bit and 8-bit here. And remember that it's really hard for you to remember 32-bit 0 and 1, right? So for that reason, for make it easier, they convert every 8-bit into the decimal, right? So you see for this one here, I see this one here, I convert it, I have 192 here. I convert it, I have 168 here. I convert it, I have 10 here, and I convert it, I have 10. So you see, when I reach 192.168.10.10, it's way easier for you to remember 0, 1, 0, 1, and so on. Right? That's the reason I require you to know the process, how to convert it from the binary to decimal, and how to convert from the decimal to the binary later on. Now, remember what I mentioned it to you, right? So IP version 4, in total, you have 32-bit, right? Now, remember one thing, one more very important concept here. Very important concept here. In 32-bit here, again, they break it down into 2 portions. They break it down into 2 portions. The first one is the network portion, and the second one is the host portion. And later on, I explained it to you why they need to break it down into the network portion and why they need to break it down into the whole portion here. But for one thing I can show you right now, if you go to your computer and you go to the command prompt here, you put the CMD here, right? You put the CMD here, the computer command prompt here. All right. So now, if you put in information about the IP config, right, and you enter, and you can see what you have in your computer right now, right? What you have in your computer right now, you see the IP version 4 address here is 172.16.0.12. That is my IP address for this computer, and every one of you have specific IP address here, right? Okay. Now, I go on with my slide here. Remember, we break it down into 2 portions, network portion and the host portion. So for this one, you see, if you look on this one, I have 24-bit. I have 24-bit for this address here. I have 24 bit in the network portion, and I have 8 bit here in the hot portion. Okay? So the reason they want to break it down in the network portion and the hot portion, because they want to group all of the computer on the same network together. So if the computer on the same network, they have the same network portion. They have the same network portion for sure, right? So see, the network portion here, 192.168.10, that means it's the network portion. So every computer on this network, they have the same network portion, but they have different hot portion. Hot portion is something exchangeable, but the network portion here, every computer on the same network, they have the same hot portion, right? So let me check again about my computer here. And you can see this one here. So you see, every one of you in this graph here, you have the same 172.16.0. You see, if you look on this one, right? Because we are on the same network. We are on the same network here, right? The network portion here is the same. But remember, it's not always 24. It can be 10 or 20, whatever it is. It depends on the size of your network. Right? For this network, you have the 24 bit in the network portion. This one, you have 24 bit, but it depends on the network. Right? Now, one very important thing again here, the more bit you have in the hot portion, the larger network it is. The larger network it is. Now see, if you have 8 bit here, if you have 8 bit here in the, sorry, what is it? If you have 8 bit here in the hot portion, what do you think? How many addresses you have? 256. Right? Because you see, you have 2 raised to the power of 8 here, you have 256. So for this network, you have the 256 in total address. But remember later on, you know that you have to reserve one for the network and you have to reserve one for broadcast. So basically for every network, you have to minus 2 here. So in total, you have 254 total address. You can give it to the computer or any device. Right? But you see, if I have the network of the 27 here and 5 here, what do you think? It's a larger network or smaller network? Smaller. Yeah, the less bit you have, the smaller network. So see, if I only have the 5 bit here in the network, in the hot portion, I have 2 raised to the power of 5. I only have the 32 address. I minus 2, I have 30. Right? So the concept here, remember, the more bit you have in the hot portion, the larger network it is. Make sense? Okay. Now, you might raise a question here. You might raise a question here. You might raise a question here. How can I know? How can I know how many bits is the network portion, and how can I know how many bits is the hot portion? If I just look into the 192.168.10.10, the same with my computer here. The same with my computer here. 172.16.0.12. I have no idea how many bits is the network portion and how many bits is the hot portion. Right? So in order to know how many bits in the hot portion, how many bits in the network portion, you have to use the concept of subnet mask. Subnet mask is the one who tell you how many bits you have in the network portion and how many bits in the hot portion, and it tell you how large network it is. Right? So what is the subnet mask? The subnet mask here, basically the subnet mask it is where? So what is a subnet mask? Wow. Subnet mask, the format of the subnet mask is the same with the IPv4. The format is the same. The subnet mask, the format is the same. What is it? The subnet mask also have the 32 bit. Remember that 32 bit, right? But it's the special thing about the subnet mask is that every bit in the network portion is number 1, and every bit in the hot portion is number 0. Right? So see, for this one here. So in order to tell how many bits in the network portion and how many bits in the hot portion, you look it up in the subnet mask. You know, right? So see for this one, you see, in total here, again, I have 32 bits. The format is the same. Break it down into 4 groups here, each of them 8 bits here. But you see, I have 8, 16, 24 here. So I look into this one. I know that this one, I have 24 bit in the network portion. And I have 80 here. That means I have 8 bit in the hot portion. Make sense? Okay. So see, if I have 8 bit number 1 here, I convert it, I have 255. If I have 8 bit number 1, 255, 255 and 0 here. That's why when I see the subnet mask 255, dot 255, dot 255, dot 0, I know for sure I have 24 bit here in the network portion, and I have 8 bit here in the hot portion. Make sense? Okay? Yes.
And earlier you had an example of 27 and 5.
Mm-hmm.
What would that look like?
Yeah. So if you have the 27 and 5, you have 1, 1, 1 here. That's all. And you draw the line here. Right? So we see. Yes, that's a very good question here. So we see what happened here. So when I have the 27 bit in the network portion, it's not 255, not 255, not 255, not 0 anymore. Right? Actually, you have to convert 1, 1, 1, 0, 0 here. So in that case, you have 224. Make sense? Okay? That's why. If you look here, if you look on that one, you know. Now, let me give you the example. Let me give you the example here. If I have network with the subnet mask of 255.255.192.0. Now tell me, what do you think? How many bits in the network portion? And how many bits in the hot portion for this one? In order to do that, you have to convert it. For sure. That's why I show you how to convert it. And you count number 1. Okay, now what do you think? 18, right? Yes, 18 is correct. 18 is correct. And how we can correct here? 8 bit number 1. I count the number 1 only, right? 255, 8 bit number 1. See, I have 8 bit number 1. This one for sure, 8 bit number 1. Right? Yeah. Now I have to convert this one for sure. 192 here, that means 1, 1, 0, 0, 0, 0, 0, 0. And of course 0 here, 0. Right? So we see 16 here, 17, 18. So for this one, I have 18 bit in the network portion and remaining 14 bit in the hot portion. It's huge network here. Okay? That's all. So that's why the purpose I show you that you have to know how to convert from the from the decimal to the binary and binary to decimal. Make sense? Okay? So is it count how many number 1? That is the network portion. How many number 0? That is a hot portion. And remember, more bit in the hot portion, the larger network it is. If you guys got it or not, let me know. Again, it's very important concept in this class. Very important concept here. Any question from you guys, let me know. Okay. So, yeah, you know that if you look into the subnet mask, you know how many bits in the network portion, how many bits in the hot portion, and you know how large network it is. What is the size of the network, right? Okay. So for the subnet mask, you have 3 ways to represent it. The first one, of course, everything in 0, 1. Everything in 0, 1. Of course, you see, you have 8 bit here. That means 8 bit in the network portion, 24 bit in the hot portion. Right? That's the first. The second one, you convert it into the decimal. Right? And the third one, normally they use it many often here. They use a slash notation. Slash 8 here, that means you have 8 bit here in the network portion. Remember, slash here, that means number of bit in the network portion, not the whole portion. Right? So see, for this one here, 27 here, that means I have 27 bit in network portion. And you see, I convert it here, 255, 255, 255, 224. Right? Because 8 bit here, 255. 8 bit here, 255. 8 bit here, 255. And 1 here, I convert it, I have 224. Is it? Okay, so remember, you have 3 ways to represent the subnet mask. Everything 0 and 1. Decimal and slash notation, or they call it a prefix flag here. Make sense? Okay. Okay, so now we come with the concept of network, host, and broadcast address. Okay, network, host, and broadcast address. So basically, for every computer in the network, you need for sure, you need specific address. And that is called the host. The host, that means the address you can give it to the computer. You can give it to the printer or server, whatever it is. Right? They are host address. And you have 2 more special address here. The first one, it is a network address. And the second one is a broadcast address. So what is a network address? Network address is the one who identifies what is the network here. So think again, if you look on this one, right? Again, if you look in the computer here, oh, I shut down it only. So we see for this one. Now, you see this one 255.255.255.0. What does it mean? How many bits in the network portion?
24.
24, right? Okay, so we see that is a subnet mask of my computer, of your computer, because we are on the same. You have the same subnet mask, right? 24 bit here, and you see this one. It is a network portion, right? This one is network portion. You have the same with me because we are on the same. But this one is not the same because it is a host. Right? So the network portion is the one who tell you what network it is. Right? So every one of you here, you have the same network portion. So that is the one who identifies the network here. Right? Identifies the network here. Me and you. Network, right? Okay. So that's the thing. That is the reason you know why do you need the network here, right? So network address, remember the network address here, it's the one with all 0 in the hot portion. All number 0 in the hot portion. Right? That's why you see it. Oh, okay, close it already. Right? That's why you see everyone here 172.16.1.0. It is a network portion. Sorry, that is a network address of all of you here. Right? So remember here, the network address here, every bit in the hot portion is number 1. Okay? Sorry, number 0, my mistake. Every bit in the hot portion, number 0. And that is the first one. Sorry, that is the first address here, right? Now, broadcast address is it. Broadcast address is that the one you want to use it to send it to everyone on the same network. Remember, on the same network only. On the same network, right? So if for this network here, if I use the IP address here, 172.16.1, you have 255 here. 255 here, that means 8 bit number 1. Right? That is the one I use if I want to send it to every one of you on this network. In this network. Right? Okay, so remember, this one, network address. This one, broadcast address. You cannot use it. That's why for every network, you have to reserve 2 of them. One is the network address, and one is the broadcast address. You cannot use them. You cannot use them to give it to the computer, server, or printer, whatever. Right? And everything between the network portion and broadcast address, they call it is a host address. Host address, that means you can use it. Right? And everything between them. So you see, everything between them. So basically for this network here, everything 172.16.1.1 and come all over to 172.16.1.254. They are host address. Make sense? And this is the first usable address. Come right after the network address. and that is the last usable address, the one come right before broadcast address. You got it? Okay. Okay, so you know the concepts of IP version 4, you know the concept of subnet mask, and you know the concept of network address, port address, and broadcast address. Okay? Okay, now, actually, yeah, that is a, back then it's very, very complicated concept here, but I show you the other way here. You know that. So basically here, before on my computer here, I want to communicate with you. That is a source, and that is destination here. That is a source and destination. So before I communicate from the source to destination, the computer only do the one action here. You have to figure it out. Is the destination here on the same network or not? So how? How can it tell it on the same network or not? What do you think? It have to figure out the network address. Because if they are on the same network, you have the same network address. All right, think about this one here. I have 172.16.1.14. It is my address, right? And if your address is 172.16.1.20, right? What do you think? They are on the same network or not?
Yes.
Why yes and why no?
Well, assuming the subnet mask.
Yes, that is the thing. If you want to tell on the same network or not, you have to make sure what is the subnet mask. Now, you see, if this one, if I have the subnet mask of slot 24 or 24 here, right? 255.255.255.0, that means I have 24 bits in the network portion. So see, 8 bit, 16 bit, 24 bit. 8 bits, 16 bit, 24 bit. Have same network portion. You are on the same network. You are same. But what do you think? If I have 255 here, 255 here, 255 here, 252 here, not the same. Not the same anymore. Because 252 here only support what? 4 addresses. Alright? Okay, and this they are, see, from here you have 6. Not the same. Right? Again, so if in order to tell the destination here on the same network or not, you have to make sure you know the IP address and the subnet mask. Without the subnet mask, you have no way to tell they are on the same network or not. Make sense? Okay? Okay. That's why it's very important to know the concept of the subnet mask. So, see, before you send it from the source to the destination here, you have to figure out if the destination on the same network. And why? Because if the destination on the same network, you can directly send it to him. The same. If I want to talk it to you, I just talk it to directly here, right? Okay? But if it's not on the same network, in the computer, they have to send it to the default gateway or home router. The home router. So after that, the home router is the one who deliver it. I have no idea, right? It might go to this way or this way or this way. I have no way. But I know for sure, if destination here is not on the same network, I know for sure I have to send it to the default network. Okay, let me do the simulation here so I can show you. I can show you the purpose of the default gateway and the purpose of the network address here. Let me open one of the simulation here. Okay. Okay. Okay, now. Here now, if you look on in my topology, if you look in my topology here, you can see what happened. I have a PC number 10 here, right? 192.168.1.10. I have .20 here, .30 here, .40 here, and they are /34, /34, /34. That means they are on the same network. Right? They are same network because the network portion here 192.168.1.1 here, right? Okay, so now you can see what happened. You can see what happened. Right, so now I do the simulation, right? Think about I want to send it from this guy to this guy here, and you can see what happened here. Yeah, I send it directly to him, right? So see, I just send it to the switch. Switch is the one who interconnects them together, and switch forward it to the destination. So that means when you are on the same network, you can directly communicate together, right? Okay, but the thing here. Okay, so see, let me do it here again. Think about this one. If I want to send it from this guy to this guy, now the first step I figured out this one is not on the same network, right? This one is not on the same network. The reason I tell it's the same network here because I know that I have /24. Sorry, I know that I have /24. So this one is my network portion, right? And this one, no way to look the same here, right? So you see, this guy here not on the same network. So what is it? Not on the same network. You have to send it to the default gateway, and you know that the default gateway is the one who deliver everything. He maintain about routing table, and he know how to deliver it to the destination. My job here is that I just send it to him. That's all. I don't care after that. The same with you here. If you want, you just send it to the default gateway. And after that, I have no idea, right? So that's why I say, if every PC here on the same network, you have to configure with the same default gateway. And what is the default gateway? Default gateway is a home router here connected to it, right? So see, if I run my simulation here, right? If I run my simulation here, and you can see, that is a home router. It is a 192.168.1.1. That is the IP address of the interface here. For every computer, if you want to go over your internet, you go over the network for sure. You have to send it to the default way, because that is the only way you go out. The same with this card, right? All of you, if you want to go out, you have to go to the door. Right? That's why. Yes.
Is the last digit of the default gateway always 1 then?
No.
Okay, it's just a coincidence.
Yeah, that I make it simple only, but it can be any number. Okay. And also, it is a host address. That means usable address.
Oh, because it's still part of the.
Yeah, it's so we see for this one here, 192.168.1.0, that is a network here. 192.168.1.0. That is a network address. Right? And 192 here, 168.1.255. This is broadcast. And everything between the number 1 and 254, they are usable address. And the default gateway also belongs to the network.
So even a router needs a
address. Usable address, not network address. Never ever use the network address and broadcast address for any device. Okay?
That could be 192.168.1.163 or
yes, that's all, whatever it is.
Any number.
But normally to make it simple and easy for you to remember, they use a first usable address. Right? That's why I use number 1 here. Okay? Okay, so we see what happened here. I want to send it from this guy to this guy here, and you can see what happened. This, you forgot it later on, I explained about the broadcast process here, but again, I do it again here. Now you see, I send it again, I send it to street, and street forward to the depot. Alright? And again, for this one also, if you want to send from this one, for sure you have to send it to depot. Alright? And now you see what happened here. For some reason, if I put the default gateway here incorrectly, right, I put number 2 here, and you see what happened here. I send it again. I send it again. Never ever go. Because I try to send it to the number 2, but no one number 2 here. Default gateway, not number 2, right? That is very important concept. Every computer on the same network, they have the same network portion and they have the same default gateway. And you see, you can see in your computer again. You can see in the computer again here, CMD here, and you put down the information about IP coverage. And you can see what happened here. Everyone for sure, you have the same default gateway. Right? Because we are on the same network. And whatever I did, if I want to go out, I have to send it to the default gateway. And he's the one who handles everything after that. Okay? Okay, that's the concept. Now, yes, I come back to my slide. Okay, this one. This one here. So, I mentioned it already. Source destination here. So before you send it out to destination, you have to figure out if it's on the same network or not. And how can you tell it's on the same network or not? You figure out the network portion. Right? And if they have the same network portion, they are on the same network. If not, you send it to the default gateway. That's all. And the default gateway will handle it after that. Make sense? Okay. So now how we do it from the computer perspective. From computer's perspective, everything they handle with 0 and 1. Right? So in order to figure out if the destination here on the same network or not, or in order to figure out the network address here, in order to figure out the network address here, you use the ANDing logic. And you know the ANDing logic in the bit there, right? If you have 0 and 0, you have 0. 0 and 1, you have 0. 1 and 0, you have 0. And 1 and 1, you have 1. So basically, you only have 1 if both of the incoming number 1, right? In any other case, you have 0, right? So think about this one. I have IP address here. I have IP address of 192.168.10.10, and I have the subnet mask here, 255.255.255.0 here. So if I want to figure it out, my network address, I have to convert it into the binary. And I have to use the ANDing logic of every single bit together to figure out the network address here. That is the way computer do it. Because you know that underlying everything, it work with the binary system here, right? So that's how it works here. 192 converted, 168 converted, 10 converted, 10 converted, 255 converted, 255 converted, 255 converted, and 0 converted. Now I'm ending them together, one by one. So 1 with 1, I have number 1. 1 with 1, I have number 1. And you see, if I have 0 here, for sure I have 0, right? So after I ending together, this is my network address. Okay, so now think about this one. I have the destination here, 192.168.15.16 here. What do you think? This guy on the same network or not? No, because the network address here, 192.168.10, right? Not 10, not 0, but this one here, 15, not on the same network, right? Okay, that's the way you figure it out. Is the destination on the same network or not? Or you have to figure out the network. And remember, that's the way computer do it. That's the way computer do it. And if you do it manually, I give you some shortcut here. If you do it manually, I give you some shortcut here. So whenever you do it to 255, you keep the same. because everything one is the same here, right? So if I see the 8 bit here number 255, I keep the same. If I see the number 255 here, I keep this one the same. If I see the 55 here, I keep it the same. Right? Okay? And if I ending with 0, I change it to 0. Right? So if you ending with 255, it's the same. If you ending with 0, change it to 0. But anything not 0, not 255, you have to convert it to binary and adding every single bit together. Okay? That's the way you do it manually. And back then, in this class, you are required to do it manually. But I don't. I mentioned it to you. You have many tools nowadays, right? You don't have to do it. Now I show you. I show you how we work with the calculator here. So in order to find out the network address and broadcast address and usable address for any address, you can use the website here. You can follow me if you want. IP subnet calculator. And you go to the IP subnet calculator, right? So think about I have IP address here, all right? 192.168.10.254, and now I can choose a subnet, right? So what happens if I have the slot 24 here, and right click on the slot 24, you can see what happened here, right? It tells me zip is a network address, and zip is the broadcast address, and zip is the usable address. Make sense? So I expect that it's up to you. You can do it manually. And now for me, already I figured out I don't need the calculator here. I figured out by myself. Whatever I did. Right? But if you don't, you can do it by the calculator here. IP subnet calculator here. You enter the IP address and you enter the subnet mask. It tells you what is the network address, what is the broadcast address here. Right? And see, you have information. You have many information here, right? Total address, usable address here, subnet mask, and so on. Make sense? And think about this one. If I change it to the 27 here, right? If I change it to 27 here, so we see that is the network address, that is broadcast address, and so on. Okay, so you know how to use it. It's up to you. You can do it manually. That's what I show you by convert everything to 0 and 1 and adding together. Or you can use the calculator here. It's up to you. All right. And I'm the instructor. I have to tell you which one is the best way to do it. All right. For me, I can do it manually, but it's up to you. I give you multiple options, and you can check whatever one works best for you here. Okay, so I think we have one video here. I want to show it to you. Yeah.
An IPv4 network need a 32-bit logical address in order to communicate. This 32-bit logical IPv4 host address consists of a network portion or network ID on the left and a host portion or host ID on the right. The length of these depends on the size of the network. Larger networks will have a longer host portion. A network can be thought of as a range of addresses. All devices on the same network have the same bit pattern for their network ID, but they will have a different host ID. Some addresses in this range are reserved and have a special name and meaning. For example, the first address in the range is used to identify the network itself, and cannot be assigned to any host. It is referred to as the network address. The last in the range is called the broadcast address and is used to send a message to all devices on the network at once. It also cannot be assigned to any host. All the IP addresses between the network and the broadcast addresses make up the usable or valid host range and can be used to address the hosts on the network. Let's take a look at how these addresses are determined. In order to forward data, a device needs to know what network it's on. Using their host IP address, their subnet mask, and a process called binary ANDing, a device can find what's referred to as the network address. This address represents the network to which the host belongs and will be slightly different than its host IP. To do this, the device compares their host IP and their subnet mask bit for bit. If the bit values are both a binary 1, the result is a binary 1. If one or both of the bit values is 0, the result is a binary 0. Let's take a look at an example. Let's say we have a PC with a host IP address and a subnet mask of 192.168.2.38/24, and we'll use ANDing to find the network address of the host. Here's the host IP in binary. Here's the subnet mask in binary. If we compare them bit for bit, we can see that a 1 and a 1 results in a 1 and a 1 results in a 1, a 0 and a 1 results in a 0 and a 1 results in a 0, and so on until we have compared all 32 bits. Notice that the last octet is all binary zeros. Because we are using a /24 subnet mask, the first 3 octets represent the network portion and the last octet is the host portion. Network addresses will always have binary zeros in their entire host portion, however long it is. In this case, the last 8 bits. If we convert to dotted decimal, we can see that this host belongs to the network 192.168.2.0/24. Now let's determine the broadcast address for this network, which is used to send a message to all devices on the network at once. Whereas the network address had all binary zeros in the host portion, the broadcast address will have all binary 1s. Since the host portion in this example is just the last octet, to determine the broadcast address, we keep the network portion the same and change the host portion to all.
But remember, broadcast address, every bit is a host portion number 1, right? And the network address, every bit is a host portion number 0. That is the first one, that is the last one, right?
All binary 1s. This results in a broadcast address of 192.168.2.255. Next, we'll determine the usable host addresses, which lie between the network and the broadcast addresses. The first usable host in binary will be all binary zeros with a binary 1 at the end of the host portion. Converting to dotted decimal, this tells us the first usable host on this network is 192.168.2.1.
Yes, that's the first usable, right? So basically, the first usable host address is the one come right after the network address, right? Is the active one, is the have come right after.
Lastly, we'll determine the last usable host, which will be all binary 1s with a 0 at the end, the opposite bit pattern of the first usable host. Converting to dotted decimal, we get 192.168.2.254.
Yeah. So the last usable is the one come right before broadcast. Right? So if you have broadcast in minus 1, you got the last usable. That's all.
Let's recap our calculations. We began with the host IP address of 192.168.2.38/24. Using binary ANDing, we determined that this host belongs to the network 192.168.2.0. Keeping the network portion the same, but placing all binary 1s in the host portion, we determined that the broadcast address for this network is 192.168.2.255. Again, keeping the network portion the same but changing the host portion, we determined that the usable host range for assigning addresses to devices on this network is 192.168.2.1, which is 1 number up from the network address, and 192.168.2.254, which is 1 number down from the broadcast address. You can see that our original host IP address falls within this range. Things to keep in mind when working with IPv4 addresses. All IPv4 host addresses are 32 bits in length. A portion of the address represents the network that the host belongs to, and that starts at the left. The remaining part is the host portion, which identifies the host on the network. And there are two special reserved addresses on every network that can't be assigned to hosts. One is the network address, which is the lowest in the range of addresses and represents the network that all the devices belong to. And the other is the broadcast address, which is the highest address in the range and can be used for a shout out to all devices on the network at once. Thankfully, there are shortcuts you can take for calculating these addresses without having to convert to binary first. But examining these addresses at the bit level should help you understand how network devices interpret them and also how the dotted decimal format is derived.
Okay, so we move to some of the concept of unicast, broadcast, and multicast. Now, the unicast transmission is sending packet to the one destination. That means one-to-one communication. One-to communication. The thing about I have the 192.16.4.1 here. I want to send it to the 253 here. I see. I send it from to the switch, and she would forward it to the other guy here. Right? That is the one-to-one communication. That's why the name is unicast here. Okay. The broadcast transmission is sending the packet to all other destination IP address. But remember, on the same network only. Right? So basically, you see, if you look on the topology here, right? Everyone here, they are on the same network. So later on, when you learn about the router, you know that the router is the one who interconnect network together. So if you have the two different network here, you need to use the router. Router is the one who interconnect network together. Switch is the one who interconnect all the computer on the same network. Remember the two concepts here, right? The switch is a connect all the computer on the same network. And the router is the one who interconnect different network together. Make sense? Okay, so see, in the case of broadcast here, it's the one from the one send it to everyone on the same network only. So see, if I want to send it to everyone, send it to one. And even this one also on the same network. But the router is the one who stop every broadcast. So the router never forward it to the other network here. And you see, if it forwarded, you are flooding broadcast all over the world here, right? That's the reason here. The router is a stop broadcast message. So if you want to send broadcast message, you send it to everyone on the same network. Right? And in many cases, you need the broadcast message here. And later on, I will show you how when you need to work with the broadcast message. Now, the third concept here is a multicast transmission. That means you send it from one to many one, but not all of them. Right? In some case, right, you want to send it to the other guy here, but not all of them. That is the case of multicast. And later on, when you learn about NetD 209, when you learn about routing protocol, you know that they work with the multicast. Okay. Now, the third section here is the types of IPv4 addressing. Right? So basically, in the IPv4, they break it down into two categories. The first one is the public, and the second one is the private. So what's the public? Public is the one who uniquely identify you all over the world, all over the internet, publicly, and you are unique publicly, right? Okay. And the second one, the private here. The private address is a common block of address used by most organizations aside the IPv4 in the internal model. So remember the key concept here. The public that means you can go anywhere in the internet, all over the world. But the private, it only contained in your network only, in your organization only. Never ever go out of the internet. And the reason they use a private IP address here because they want to save it. You know that if you have 32-bit, right? If you have 32-bit in the IPv4, you have 2 raised to the power 32 you only have the 4 billion. Nowadays, run already. Yeah, run already, right? So the reason they use a private here because they want to save. Then why you save it? Because you can reuse it. So we see my computer here is 172.16.1.10. At home, I can use the same 172.16.1.10. It doesn't matter because it belongs to two different networks. Right? I can reuse it. And the reason they use a private here because they want to save the public address. But remember, the private here, it only contains your network. You cannot go over the internet. If you want to go over internet, you have to translate it from the private to the public. That's the reason here. You see, you are the private here, right? All of you here private here, but you're still able to go internet. And the reason because you translate it into the public. And the reason it said is that because for one public IP address, you can accommodate for hundreds private IP address. Right? That's why it said the public here. Okay? Okay, so remember you have two categories here. The public, that means you uniquely identify all over the network, all over internet, all over the worldwide here, right? And you can route to anyone. But the private only contained in your network. Make sense? And they have the three ranges of the private here. Have the three ranges of private. The first one is number 10 here. So if you see any IP address starting with number 10, for sure, it is private. The second one is from the 72.16 to 72.31 here. It is a private. That's why you see you have the 72.16 here, right? And the last one here is very common. You see in the home network, right? 192.168. So if you see any IP address starting with 10 or anything with from the 172.16 to the 31, it is private. Or anything starting with 192.168, it is a private. Make sense? Okay. And remember, it's very important that private here, they are not globally routable. You cannot go over internet. If you want, you have to translate it. And when you learn about the NAT 119, they use a NAT here. NAT here, that means network address translation. You have to translate it from private to public in order to go to the internet. Okay. Okay, that is network address translation. Network address translation here. Now you have